let's just review. They wanted us to show how sine squared theta plus cosine squared theta equals 1 comes from the Pythagorean theorem. So we started out with our right triangle, right? Because we have to have a right triangle in order to use the Pythagorean theorem. Put that right triangle in our unit circle. Obviously, we're working with trig here. All right, we labeled our two legs as A and B, and our hypotenuse as C. That's what we know them as. From there, we remembered that, hey, it's the radius of the unit circle. That's 1 squared. C is just 1. So 1 squared, that's still 1. Here we're just realizing that we can rewrite this over 1 because any number is over 1. We just don't write it as a fraction all the time. So this step is just us rewriting it to maybe pull some other algebra out of it. If you're missing any of these steps, I would highly suggest putting them in because it makes a lot of sense sequentially to go through this, and you'll see exactly how we get to sine squared theta plus cosine squared theta equals 1 from all of these steps. So we're on this step here. A squared over 1 plus b squared over 1 equals 1. We can rewrite a squared over 1 as a over 1 squared. Why can we do that? Why is that allowed? Has something to do with rules of exponents. Do you know what we do with this squared? If we wanted to simplify, we distribute this squared to the top and the bottom. So that's a squared over 1 squared, which is just 1. So it's equivalent. That's what I'm saying here. That we're allowed to write this like this because it's equivalent. And that's the same thing goes for b over 1 all squared. It's the same thing as b squared over 1 squared, which is just b squared over 1. You see how we can go this way? It's a little abstract thinking, but that's how we're going to pull out our identity from this. So the next thing, I should keep the picture there. So now we have these ratios squared. Doesn't matter about the squared right now. Let's look at the ratios. We notice that a over 1 is adjacent over hypotenuse to this angle theta, right? We're concerned about theta right now. And so we see that to theta, it's adjacent over hypotenuse, and once again, it's still squared. And b over 1 is just opposite over hypotenuse, which is where we're getting that. Still squared, and you notice the whole time we're bringing down equals 1. That hasn't changed. Adjacent over hypotenuse is equal to what? Adjacent over hypotenuse, that's like our trig ratios from that right triangle trig packet. What's it equal to? Adjacent over hypotenuse? Cosine. Adjacent over hypotenuse is cosine, and opposite over hypotenuse is sine. But notice how we have these squared, so these have to be squared. And I know it looks funky, but this is just how you write them squared. You would think cosine theta squared or sine theta squared, but we just write the squared in between. That's just how the notation, just something funky that happens in math. So we get cosine squared theta plus sine squared theta equals 1. And we just switched around sine squared theta and cosine squared theta because you can do that with addition, right? We got our identity. We walked through just looking at a situation where the Pythagorean theorem applies, did some algebra, used some trig ratios, and we got our super, super important Pythagorean identity. Does everyone see that? Does everyone follow all the steps? Yes or no? Yes? I see some nods. Okay, that's good. All right. If you understand that, we're going to move to example 2. Why? There we go. Okay. Example 2. They want us to use what we just established, use sine squared theta plus cosine squared theta equals 1 to show that this is true and this is true. Okay? So we'll do this one together, and then I'm going to have you try this one on your own. So let's start out by writing where we have to start, kind of like we started with the Pythagorean theorem. We're going to start with sine squared theta plus cosine squared theta. I'm not going to write equals 1 yet. You'll see why. Sine squared theta plus cosine squared theta. Okay, so if this is what my end goal is, this is where I'm trying to get, how can I maybe, let's look at tangent squared theta. How can I get one of these things to look like tangent squared theta? Like, what's the relationship between maybe sine squared theta and tangent squared theta? You can flip back to your page. Where is there an identity that tangent and sine are both in, or tangent and cosine are both in? We're trying to get tangent squared theta in terms of sine and cosine. Anyone see it? Alex, yeah. Yeah, okay, so let's give that a try. Sine over cosine squared theta. Okay, so now we're relating it to our end goal, basically. But you can't just do that. What do you need to do? You need to put this one over cosine squared theta also. What does that give you? If you have two fractions and they have the same bottom, what is that called? This, so I'm asking what is it called? What is it called whenever you have two fractions and the bottoms of them are the same? So now you can add or subtract them. It's two words. Common denominator. Do these have common denominators? Yes. So what can we do to the top? Add. All right, so let's do that. We have a common denominator here. We put both of them over cosine squared theta because we wanted to get this relationship in there somewhere. So now let's try and add across. So we have sine squared theta plus cosine squared theta all over what? Cosine squared theta. Just checking your adding fraction skills. All right? That numerator looks like something. What does it look like? I'm asking, so if we're looking at, whoa, this, what does that look like? Yes. It does equal 1. You're exactly right. Up here it says sine squared theta plus cosine squared theta equals 1. Okay, so we know what that's equal to. 1 over cosine squared theta. Can someone tell me what 1 over cosine squared theta equals? We know that too. Secant squared theta. Yeah, if it's squared, you got to keep the squared coming along. Secant squared theta. Okay, so we just started with sine squared theta plus cosine squared theta, used some common denominators, some adding fractions, and identities to get it equal to secant squared theta. So now let's look back at what we started with. Chase, what is this fraction equal to? 1. We can bring that down, right? That's a fact. Cosine squared theta over cosine squared theta is equal to 1. What is this equal to? It's the whole reason we started like that. What is it equal to? Tangent squared theta. Exactly. We put it over cosine squared theta so that we could get this in there. Tangent squared theta. Okay. What did you guys just do? You just established that identity. You just went through and got common denominators, did some algebra, used some trig functions and ratios and identities, and you established that last one. Do you notice that you're dividing the whole thing, the whole equation, by cosine squared of theta? That's all you're doing. Sine squared theta over cosine squared theta. Tangent squared theta. Cosine squared theta over cosine squared theta. 1. 1 over cosine squared theta. Secant squared theta. So you're taking that first identity and you're dividing it, the whole thing, by cosine squared theta. Yes. So the answer for this wasn't anything specific. It was the idea that could we show, starting here, how to get to here. So the answer is in the work. The answer is, did you start with this identity and use all the correct identities throughout to get to what they wanted us to get to? And we did. So we'll do one of these. Do you see what I'm saying? How we worked through and used different trig ratios and maybe adding some with common denominators and different identities to get our final answer. And the whole way we started was by seeing, hey, I need to get tangent squared of theta involved somehow. And that's why we chose cosine squared theta in the bottom. So I want you to take a moment on your own to try B. You're going to start the same way we started. It tells you to start like this. This is our starting point. And then I'd say probably get cotangent squared theta involved somehow. We got tangent squared theta involved. Use the same steps. It's just going to be a little bit different in terms of what trig ratios and identities you use. But it's going to be the same process to deduce how we get to 1 plus cotangent squared theta equals cosecant squared theta. All right, I see that a lot of people are getting this very quickly, which is awesome. So to get cotangent squared theta involved, what is cotangent squared theta in terms of cosine and sine? Cotangent in terms of sine and cosine. A little bit different. Yes, it is. You are correct. So you can't do that just to one piece. Got to do it to both. We have a common denominator now. We can add the tops, leave the bottom. Sine squared theta plus cosine squared theta. That top is equal to that first identity, which is equal to 1. So we have 1 over sine squared theta, which is, what's 1 over sine squared theta? I hear it. Cosecant, thank you, squared theta. All right, let's see what we started out with. Sine squared theta over sine squared theta, 1. Cosine squared theta over sine squared theta. Chase told me that was cotangent squared theta. We get our third Pythagorean identity. So what you're seeing here is that these two Pythagorean identities come from this first one. If you can remember the first one, you have the other two. You just figured them out using just that one identity. So I'd say that's a little nice trick there. If you get that identities quiz next week, if you're having a hard time remembering those, that's all you got to do is divide this one by sine, the other one by cosine. And if you're not remembering, you'll notice that it doesn't work out if you do divide by sine here, you would get 1 over sine. You'd get tangent with, it just would not work out. You could try, it wouldn't work out. You would have to need to, well, I guess it would work out, because either way you're going to get one or the other. If you're going for one, you would need to make sure you're dividing by sine or cosine. But if you're just trying to get them, divide cosine squared theta plus sine squared theta by cosine squared or sine squared. And you get these two. What I'd like you to do now is flip on over to, it says review packet operations with rational expressions. I'd like you to do the Fast 5 warm-up. You have a little bit of time. Your homework is to finish this review packet. It is 4 pages. This is one of the pages, this warm-up. 1, 2, 3, 4. On the 5th page, it looks like this, guys. Can I have your attention? The 5th page looks like this. This isn't part of your homework. See, I have an X through it. It's 1 through 4 that is your homework for tonight. So I would get started on that. At least get the warm-up done. You have a couple more minutes. Yes.